Okay. So now, Anshul, Siddharth,
So 1 second.
yeah.
2 minutes, 2 minutes. I'll just start.
When I switch on your video. Okay, so what I was saying that periodic table is on your screen, है ना? So देखा है कभी ध्यान से इसको गौर से what elements are placed where? Have you seen it? या फिर कभी नहीं देखा? ओके अगर नहीं देखा है या जो मैंने बोला इफ यू हैव नॉट सीन इट केयरफुली स्टार्ट ऑब्जर्विंग इट केयरफुली क्योंकि इट विल स्टार्ट टुडे एंड इट विल एंड एट जेई एग्जाम मतलब एवरी टाइम whenever we'll be talking about complete inorganic chemistry and many portion of the physical chemistry also I'll be referring to the periodic table time and again. Okay. So what we need to do, we need to refer to the periodic table and it will help you also because today itself we'll talk about that key, how the periodic table has been prepared and why it is important to classify or do the classification of the elements in various groups and rules. है ना? So we'll understand the basic points, how they have prepared this particular periodic table. If you see it completely, देखो ये जो version है that I am showing you, it has been taken from the official website of IUPAC. ठीक है? They have the role of preparing the periodic table. So this is the latest version which I have got from the website. ये 2022 का latest updated version है. इसके बारे में तो बात करेंगे ऑब्वियसली उसी के नीचे देखोगे मैंने एनसीईआरटी वाला भी वर्जन दिया देयर आर 1-2 डिफरेंसेस इन बिटवीन दोज टू वर्जन्स आई विल एक्सप्लेन दैट और दैट आल्सो सो दैट्स वन पार्ट इसमें तो जाएंगे कि हाउ द पीरियोडिक टेबल हैज बीन प्रिपेयर्ड उसमें थोड़ा सा एटॉमिक का सीक्वेंस जो हम लोगों ने वहां पर जहां छोड़ा था दैट पॉइंट वाज इलेक्ट्रॉनिक कॉन्फ़िगरेशन इन द एटॉमिक स्ट्रक्चर है ना आर यू क्लियर अबाउट एटॉमिक द इलेक्ट्रॉनिक कॉन्फ़िगरेशन Okay, ठीक है तो फिर that will help you in this chapter also. So what we are going to do first तो we'll understand that कि why it is required to do the classification of the elements in various groups or subgroups or the periods. The horizontal rows here are called periods. The vertical column here are called groups. Okay. So we need to understand that कि why this type of situation was brought कि एक के ऊपर दूसरे को दूसरे के नीचे तीसरे को ऐसा कुछ रखने की जरूरत पड़ी क्यों है ना दैट वी वांट टू अंडरस्टैंड सो इस पे वापस आएंगे बट द फर्स्ट पॉइंट इज विल बी टॉकिंग अबाउट व्हाट वाज द नीड ऑफ द क्लासिफिकेशन ऑफ द एलिमेंट्स एंड फॉर दैट वी नीड टू अंडरस्टैंड की फर्स्ट थिंग if I give you na there are many books also based on one particular element or some groups of compound also but in order to make the study easier we need to follow the scientific method and the best method will be that जो similar type के compound जो similar type के elements आ रहे हैं उनको put them in one group है ना that's the simple thing that most of the time we'll be talking about if I'm teaching you the S block element which is having sodium as well as potassium you'll be observing that many of the properties of sodium and potassium will be matching okay and that is having some basis जिसकी बात आज करेंगे हम लोग that's one part so it will make the study and the observation and the related application easier that's one point second point is to predict the properties of elements yet to be discovered like right now if you see the periodic table na, if you see the modern periodic table that is having 118 elements है ना we have got 118 elements in the modern periodic table. But I can tell you कि जब भी 119th element discover होगा, what will be the place of that element in the periodic table? What will be the expected property of that element? ये सारी कहानी जो है ना, in fact, if you go to the history वाला part, Mendeleev was the most famous person जिसके नाम पे periodic table बना. I'll give you a little bit of history also, but नॉट वेरी मच रिक्वायर्ड फॉर जेई पर्टिकुलरली एडवांस के लिए तो बिल्कुल भी नहीं चाहिए मेंस के लिए भी जो चाहिए वो छोटे छोटे जो पॉइंट्स डेविनर ट्राइड लिखे हुए एनसीईआरटी में न्यूमैन्स ऑक्टेव रूल जो था वो लिखा हुआ है एक थोड़ा सा लोथर मेयर कर्व आता है जो हिस्टोरिकली थोड़ा सा सिग्निफिकेंस रखता है अदरवाइज इफ यू सी द एडवांस का सिलेबस दे आर नॉट वरीड अबाउट द हिस्ट्री दे आर सिंपली टॉकिंग अबाउट की मॉडर्न पीरियोडिक टेबल में जो है उसकी बेसिस पर लेट्स टॉक अबाउट व्हाट एवर इज प्रेजेंट राइट ठीक है तो दे आर जेई एडवांस इज नॉट इंटरेस्टेड इन द हिस्ट्री वाला पार्ट ठीक है तो ये ग्रुपिंग की हिस्ट्री कैसी है people started observing that some elements may have similar properties also. So initial version, why they failed also, that also I'll tell you that why they failed. Initial version was having the basis of atomic mass, that I need to observe the elements with the atomic mass, and that's why we have understood that during the Moseley's experiment that uh, elements are having properties based on their atomic number and not on their atomic masses, है ना? Because the atomic number is also numerically equal to the number of protons in their nucleus, and that is going to decide the property of the element, है ना? Because those protons are going to attract the electrons, and that's why the properties will be based on the interaction of the electron and the proton in the nucleus, and that is depending on the value of Z. So it has nothing to do with the atomic mass, but generally you will observe that when atomic number increases, atomic mass also increases, है ना? तो इसकी बेसिस पर लाइक देयर वर डोबिनेर ट्राइड, डोबिनेर वाज द नेम ऑफ द साइंटिस्ट, उन्होंने क्या किया, तीन तीन एलिमेंट्स का ग्रुप बनाया इन विच दो का एवरेज निकाला तो तीसरे के ऑलमोस्ट बराबर जैसा दिख रहा था, एंड दैट वाज कॉल्ड डोबिनेर ट्राइड, ठीक है? उसी के बाद फिर ट्राइड के बाद टेट्राड आया, फिर पेंटाड आया, मतलब ग्रुप ऑफ 5 एलिमेंट्स, ठीक है? तो ये पूरी स्टोरी चली। इसके बाद जो लॉन्ग टर्म में अगर हम लोग देखेंगे तो वी हैव नेम ऑफ टू साइंटिस्ट जिन्होंने मेजर कंट्रीब्यूशन दिया, एंड दैट वाज एक न्यूमेंस ऑक्टेव रूल भी था, दैट वाज कि इफ यू आर arranging the elements in their atomic masses, every eighth element should have the property same to the first element. In fact उनका इतना मजाक उड़ाया कि वो डिप्रेशन में चले गए। इतना क्या बोला गया उनको कि ये उन्होंने कंपेयर कर दिया था the elements के number in a row with the notes of the music, and that's why he was ridiculed. And उसके बाद उनको इतना इतना मजाक उड़ाया, इतना मजाक उड़ाया, तो बाद में जब मेंडलीफ ने अपना पीरियोडिक टेबल दिया तो ही स्टार्टेड क्राइंग कि अरे ऐसा ही कुछ तो किया है, ठीक है, मेरा वर्जन वाज विद द डिफरेंट लैंग्वेज, बट चीजें तो सेम ही दिख रही है, सिमिलर ही दिख रही है, दैट्स व्हाई बाद में ऐसा नहीं कि उनको कंट्रीब्यूशन के लिए रिकॉग्नाइज नहीं किया गया, ही वाज आल्सो रिकॉग्नाइज्ड फॉर हिज कंट्रीब्यूशन। बट बाद में मेंडलीफ वाज द साइंटिस्ट हु वाज वेरी प्रैक्टिकल इन अप्रोच, जैसे मैं बोर की कहानी सुनाता था ना एटॉमिक स्ट्रक्चर के टाइम पे, वैसे मेंडलीफ वाज आल्सो वेरी प्रैक्टिकल गाय। तो इनफैक्ट ही वाज इन्वॉल्वड इन मेनी बिजनेसेस आल्सो। तो एक दिन उनकी एक विजिट प्लान्ड थी टू अ चीज फैक्ट्री, बट वो ही वाज ऑलरेडी वर्किंग ऑन द पीरियोडिक टेबल की कुछ तो ऑर्गेनाइज करना है एलिमेंट्स को। ही मेड पैक ऑफ कार्ड्स बेस्ड ऑन द एलिमेंट्स, है ना? और उसके बाद उसको रैंडमली वो ऐसा पीस करने लगे, और उसके बाद फिर धीरे धीरे ही गॉट द आइडिया कि हाउ टू अरेंज देम सो दैट वी कैन गेट सिमिलर एलिमेंट्स इन द सेम रो, एंड देन ऑल द प्रॉपर्टीज वर एस्टैब्लिश्ड। नाउ व्हाइल डूइंग दैट ही फाउंड दैट कि कभी कभी गड़बड़ हो रहा है, मतलब अगर इफ यू आर स्ट्रिक्टली फॉलोइंग द ऑर्डर ऑफ एटॉमिक मास ना, कभी कभी गड़बड़ हो रहा था कि ऊपर नीचे वाले एलिमेंट्स की प्रॉपर्टी सिमिलर नहीं भी आ रही, and that's why he changed the position of the elements also based on their properties, even if it was not following the order of atomic mass. तो उनको एनोमेलस पेयर कहा गया। तो कभी कभी देखोगे कि जैसे आप पोटेशियम एंड आर्गन का पोजीशन देखोगे, तो आर्गन इज प्लेस्ड फर्स्ट देन पोटेशियम, जबकि आर्गन का एटॉमिक मास इज स्लाइटली ग्रेटर देन द एटॉमिक मास ऑफ द पोटेशियम, ठीक है? दैट्स वन पार्ट। बट उन्होंने ये भी बता दिया था, आई जस्ट शो यू द पीरियोडिक टेबल अगेन कि व्हाई आई एम टॉकिंग अबाउट द सेकंड पॉइंट सो मच। एल्युमिनियम के नीचे जानते हो क्या है? यू नो द पोजीशन ऑफ द एलिमेंट इन बिलो एल्युमिनियम, व्हाट इज द एलिमेंट प्लेस्ड बिलो एल्युमिनियम?
गैलियम।
गैलियम है। तो जब मेंडलीफ अपना पीरियोडिक टेबल प्रिपेयर कर रहे थे ना, गैलियम वाज नॉट डिस्कवर्ड, जर्मेनियम वाज नॉट डिस्कवर्ड, ठीक है? व्हाई इट इज नॉट? या या सो इफ यू सी द पोजीशन ऑफ द एलिमेंट्स ना, एल्युमिनियम के नीचे जो गैलियम दिख रहा है, दिस वाज नॉट डिस्कवर्ड एट दैट टाइम। सिमिलरली जर्मेनियम वाज नॉट डिस्कवर्ड एट दैट टाइम, but he predicted that whatever element will be placed below aluminum and silicon ना, उसकी प्रॉपर्टी ऐसी ऐसी होगी। ही प्रेडिक्टेड सो क्लोज ना कि जब डिस्कवर हुआ तो पता चला कि व्हेन दे कंपेयर्ड द प्रॉपर्टी, बोला बेंटलिम ने जो बोला, तो ऑलमोस्ट इट वाज मैचिंग विद द प्रॉपर्टी ऑफ द एक्चुअल गैलियम एंड जर्मेनियम, है ना? So that's why I told you that one point is we can have the prediction about the properties of those elements also which are yet to be discovered. Is it okay? Clear है सबको? Now that's second point. Third point, already I mentioned that in many applications you will be seeing that ki if you take potassium in place of sodium or sodium in place of potassium, na, it will not very much affect the properties of those compounds or the related applications. And that's why in many chemical and biological applications, you can replace one element with the other which are matching in the property. अब इसकी एक हिस्ट्री है. हिस्ट्री क्या है? देयर वाज अ कोल्ड ड्रिंक, अभी नाम नहीं बताऊंगा, थोड़ी देर के बाद बताऊंगा. देयर वाज अ कोल्ड ड्रिंक जिसके प्रिपरेशन में इफ यू वांट टू हैव दैट लेमन लाइम फ्लेवर ना, तो दे यूज्ड टू पुट सोडियम साइट्रेट. ठीक है. अब एक बंदा था जिसको लगा कि अगर अरे पीरियोडिक टेबल में मैं देख रहा हूँ यहाँ सोडियम है, सोडियम के ऊपर लिथियम भी तो है, तो सोडियम पोटेशियम साइट्रेट तो पूरी दुनिया यूज कर रही है, लेट मी यूज द लिथियम साइट्रेट. तो दे स्टार्टेड यूजिंग द लिथियम साइट्रेट. और उन्होंने जो नाम रखा था इनिशियली, द नेम वाज लाइक बिब लेवल लिथिएटेड लेमन लाइम सोडा. फिर धीरे धीरे उसको मॉडिफाई वगैरह किया गया, वो चीज आई. और फिर उसके बाद ऑलमोस्ट इट वाज लॉन्च्ड इन 1924 या 29 जैसा कुछ टाइम था, उस समय इसको लॉन्च किया था. उसके 20-25 साल के बाद पता चला कि फूड एंड ड्रग एडमिनिस्ट्रेशन डिपार्टमेंट ऑफ द यूएस है ना, उन्होंने बोला कि ये लिथियम तो यूज ही नहीं किया जा सकता है नॉर्मल ड्रिंक्स में, बिकॉज लिथियम इज कंसिडर्ड टू बी मूड स्टेबलाइजर. साइकियाट्रिस्ट वगैरह अपने ट्रीटमेंट में उसको यूज करते हैं, लाइक मैनिया होता है, डिप्रेशन होता है, बाइपोलर डिसऑर्डर होता है. इन सब के ट्रीटमेंट में लिथियम इज वन ऑफ द इंपॉर्टेंट कंपोनेंट इन द मेडिसिन. दैट्स वाई उसको बैन किया गया 1948 में. और उसके बाद बोला गया कि नहीं भाई ये नहीं चलेगा, उसकी जगह वापस आ जाओ सोडियम एंड पोटेशियम साइट्रेट पे. तो समझ लो कि एक कहानी ऐसी हुई कि 20-25 साल तक उन लोगों ने कोल्ड ड्रिंक में लिथियम पिलाया लोग. अभी उसको नहीं पिलाया गया. इनफैक्ट जब वो लॉन्च किया गया ना, जब वो लॉन्च किया गया तो उसपे ऐसे ऐसे वर्ड्स लिखे गए जैसे लग रहा था कि ये कोई मेडिसिन बेच रहा है. जैसे आई मेंशन सम ऑफ द वर्ड्स, इट सेटल्स द स्टोमक फॉर हॉस्पिटल और होम यूज. The added citrate neutralizes free acid. The sugar is inverted, burns clean. 7 Up is this is a mixer. It blends out the harsh features, dispenses hangover. Take the ouch out of grouch. Accidentally, I have taken the name. लिथियम का एटॉमिक मास कितना है पता है? You don't know? देखो जरा, दिख रहा है क्या? इधर नहीं दिख रहा है आपके. लिथियम का एटॉमिक मास इज अप्रोक्सीमेटली 7. ओके. एंड द कोल्ड ड्रिंक का नेम वाज 7 अप, जो तुम अभी पीते हो. 7 अप जो स्टार्ट हुआ था ना, इट वाज स्टार्टेड लाइक, आई जस्ट शो यू द पिक्चर. उसका बड़ा इंटरेस्टिंग पिक्चर आया था, जो इनिशियल वर्जन आया था उसका एड. इफ यू सी इट ना, ऐसा लगेगा ये मेडिसिन बेच रहे हैं कोल्ड ड्रिंक की जगह. देखो जरा, दिस वाज द उनका label over the on the bottle and in the ads also. Lithiated lemon soda 7 Up settles the stomach, hospital and home use. Added citrate neutralizes free acid. It dispels hangovers. Takes the ouch out of grouch. मतलब पेट वेट ठीक कर देगा, चेहरे पे चमक आ जाएगी. सब बातें बोल दी उन्होंने कोल्ड ड्रिंक के नाम पे. और बाद में पता चला कि लिथियम can't be used in this type of regular drinks. You have to replace lithium by some other element. एंड दैट वाज वन ऑफ द इंपॉर्टेंट पॉइंट जहां से रियलाइज किया गया कि ऐसा कर तो सकते हैं कि वी कैन रिप्लेस वन एलिमेंट विद द अदर. बट जैसा मैंने यहाँ इंडिकेट किया है, नॉट ऑल. ऐसा नहीं कि कहीं भी किसी को उठा के लेके जस्ट बिकॉज इट्स प्लेस इन द पीरियोडिक टेबल इज अबव सम एलिमेंट और बिलो सम एलिमेंट, उठा के उसको नहीं खा लेगा. सिंपल सी चीज. ठीक है. तो दैट वाज द मैसेज कमिंग फ्रॉम दिस वन, दैट in many applications but not in all the applications, and applications mostly are chemical and biological. You cannot use all the elements, but many of the elements can be replacing each other in terms of their applications of the properties. Is it okay? Clear point? Okay, now let's come to the periodic table. कैसा बना है, what was the basis, and then we'll start understanding कि इसमें चीजें क्या क्या आ रही हैं. तो पहले बहुत ही बेसिक कंपोजिशन समझ लेते हैं, and then we'll start टॉकिंग अबाउट कि इसका प्रिपरेशन जो किया है ना वो कैसे आया है. इफ यू सी द बेसिक पॉइंट जो दिख रहे हैं ना पीरियोडिक टेबल में, इफ यू सी इट, वी हैव गॉट, ऐसे देखो आईयूपीएसी ने हाइड्रोजन को ऊपर रखा है. बट इफ यू सी द एनसीईआरटी का, यहाँ देखो हाइड्रोजन हैज बीन प्लेस्ड सेपरेटली, है ना। तो इस पे एक पूरा डिस्कशन है दैट इट्स पोजीशन इज कंट्रोवर्शियल, बट आई विल टेल यू द राइट वर्जन, द करंट वर्जन। बाद में चीजें बदलती है, जैसे देयर इज एन ऑनगोइंग प्रोजेक्ट फॉर द आईयूपीएससी, इट इज written on the IUPAC website also, that they are trying to identify कि ये lanthanum जो दिख रहा है ना, यहाँ पर देखो ये lanthanum दिख रहा है ना, यहाँ स्टार लगा है, 57 इज द एटॉमिक नंबर। उसके नीचे देखो यहाँ 58 से लेकर ना 71 है, और फिर 72 इज देयर। इसका मतलब है ये 57 से 71 have been given the same place in the periodic table because there were 15 elements, इसलिए एक को वहां रखा है, बाकी 14 नीचे रखा है। इफ यू सी द एनसीईआरटी वर्जन, इन्होंने यहाँ डायरेक्टली इंडिकेट कर दिया है 57 टू 71, एंड देन 57 टू 71 दे हैव प्लेस्ड बिलो सेपरेटली इन अ डिफरेंट रूम, है ना। What is the case? The case is that they are analyzing that whether to put all these 15 elements in F block, or to put lanthanum in D block and then remaining 14 in the F block, or to put lanthanum to yttrium wala up to the atomic number 70 wala in the F block, and then rotation in the T block. This project is ongoing, and जब भी अपडेट आएगा तो आई विल टेल यू। राइट नाउ मैं 2-3 साल से देख रहा हूँ, ऐसा कुछ उन्होंने चेंज नहीं किया, ठीक है। दैट्स वन पार्ट। नाउ इफ यू सी द होल पीरियोडिक टेबल हाउ इट हैज बीन प्रिपेयर्ड, हाइड्रोजन तो ऑलरेडी मैंने बता दिया। तो इफ यू सी इट इज इन द सीक्वेंस ऑफ एटॉमिक नंबर, बट इट इज नॉट लाइक कि एक ऐसा स्क्वायर ब्लॉक बना हुआ है जिसमें पीरियोडिक टेबल के एलिमेंट्स हैव बीन प्लेस्ड, है ना। इट इज लाइक कि पहले रो में इफ यू सी देयर इज ओनली हाइड्रोजन एंड हीलियम, देन इफ यू हैव इफ यू सी लिथियम एंड बेरिलियम इज देयर, एंड देयर इज गैप 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 गैप, उसके बाद फिर वी हैव गॉट बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन एंड नियोन, है ना। फिर again there is a change of row, and we have got sodium, magnesium, and then there is a gap of 10 elements, and then after that we are getting aluminium to argon. फिर से जब रो चेंज किया ना, this time there is no gap. Potassium is there, calcium is there, then scandium to zinc is there, which was not earlier present in the previous row, and then gallium to krypton is there. उसके बाद फिर ये रेगुलर दिख रहा है ना। इफ यू सी मैंने जैसा बताया सिक्स्थ रो, इफ यू सी सीजियम बेरियम के बाद यू हैव गॉट 57 टू 71 एटॉमिक नंबर इज प्लेस्ड एट द सेम प्लेस। इट हैज बीन गिवन द सेम प्लेस इन द थर्ड ग्रुप। इट इज थर्ड ग्रुप, सिक्स्थ पीरियड, एटॉमिक नंबर 57 टू 71, एंड देन 72 से लेकर 80 तक देयर आर एलिमेंट्स फ्रॉम हाफनियम टू मर्क्यूरी, एंड देन यू हैव गॉट थैलियम टू रेडॉन कंप्लीटिंग द रो। उसके बाद फिर से फ्रांशियम एंड रेडियम के बाद इफ यू सी अगेन 89 टू 103, these are the atomic number present at the same place, and after that if you see Rutherfordium से लेकर oxidation तक you have got 118 elements, and then we have completed the currently discovered element, there are 118 elements. Is it okay? Clear the point? Now let's discuss that ki how this periodic table has been prepared. ठीक है। if you remember हम लोगों ने last class uh, in the last lectures of atomic structure we discussed that how the subshells are arranged in their energy level according to the order of their energy levels, है ना। और उसके लिए n+l rule पढ़ा था ना, and we have started discussing that first you have to put the electron in 1s, then 2s, then 2p, then 3s, है ना। this was the sequence, and I told you that if you discuss that n+l rule यहाँ पर कैसे काम कर रहा है, तो I'll just show you। if you see this one, this is having n plus l equals 1. This is having n plus l equals 2. All these two subshells are having n plus l equals 3. This is having n plus l equals 4, n plus l equals 5, n plus l equals 6, and so on. So n plus l is increasing in this direction. This value is increasing. And for a given n plus l, this is the direction in which n is increasing. Okay. So if I have to fill the electron, first we'll be filling it in 1s, then we'll be filling it in 2s, then 2p, then 3s, then 3p, then 4s, है ना? This is the sequence. Is it okay? Now, let's go to the NCERT वाला version क्योंकि उसमें already electronic configuration has been written, and that's why it will be more helpful. बाद में हम लोग डिटेल में बात करने वाले हैं कि where are the what are the elements in which we have got exceptional configurations also. In this chapter, we are going to cover the electronic configuration of all the 118. And I'll give you the trick, little bit of trick, कि जहां एक्सेप्शन है उसको कैसे याद रखने का है, बट अदरवाइज वी आर गोइंग टू डिस्कस डेफिनेटली इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ ऑल द 118 एलिमेंट्स, ठीक है, एंड देयर विल नॉट बी एनी प्रॉब्लम। कहीं कहीं एक्सेप्शन जो मिलता है उसका ट्रिक मैं बता दूंगा, अदरवाइज मैं पोजीशंस बता दूंगा, ठीक है। तो नाउ इफ यू सी द फर्स्ट पीरियड जिसको बोलते हैं, जिसको हाइड्रोजन को इसने अलग रखा है, तो इफ दे आर आस्किंग यू हाइड्रोजन का पीरियड क्या है, तो विल से वन फर्स्ट पीरियड इज द, अच्छा, हॉरिजॉन्टल रोज आर कॉल्ड पीरियड्स, वर्टिकल कॉलम्स आर कॉल्ड ग्रुप्स। हाउ मेनी ग्रुप्स आर देयर?
18.
18.
18 ग्रुप्स आर देयर, है ना, एंड हाउ मेनी पीरियड्स?
7.
7.
7 पीरियड्स आर देयर, है ना। दीज आर द पीरियड नंबर, देखो 1 लिखा है, 1 का मतलब दिस इज द फर्स्ट पीरियड एंड हीलियम इज आल्सो इन द फर्स्ट पीरियड। नाउ इफ यू सी द कॉन्फ़िगरेशन ना, 1s1 is the configuration of hydrogen, 1s2 is the configuration of helium. Now when to change the row, that means when to change the period, for that there is a rule that in nth period, the last subshell of that period, sorry, NP of that period, NP subshell of that period will be fulfilled, completely filled, except the first one, because first one doesn't have P subshell, है ना, 1s होता है, 1p होता ही नहीं, and that's why in first period we are filling 1s1 and 1s2. Remaining in all the periods will be starting at ns and will be ending at np subshell. Is it okay? Like if you see, the second period is starting at 2s1 and it is ending at 2s2 2p6, because 2p is having capacity of 6 electrons, you know, 2p subshell. So if you see the whole periodic table, what is happening here? First period, hydrogen helium, because there was 1s1 1s2 filling. Second period, if you see, it has started with lithium, which is 2s1, then we'll be filling 2s2, then we have got 2s2 2p1, because 2s ke baad we are going to get 2p. Achha, why there is a gap? Because in future there will be filling of 3d 4d, aisa bhi filling hoga na, and that will be happening if I am filling 3d, so 3d ke baad I'll be filling 4p, hai na. If you see the sequence, 3d will be filled first and then 4p is going to be filled, hai na. And that's why, just to see that ki in future we are going to get some elements in between this column and this column, and that's why there was a gap left in first, second, and third period. Is it okay? Clear the point? Now let's go to second period. Second period was started at 2s1 2s2. There is no 2d or something like that, or 1d like that, so that's why we are moving to 2p to 2p6, 2p1 to 2p6. After that 3s will be filled, so 3s1 is the outermost configuration of sodium, obviously after neon, and then 3s2 is for magnesium, and then 3p1 to later 3p6, we have got the configuration of the third period. Is it okay up to this point? Any doubt? Now we are coming to the fourth period, and then the sequence matters, because in fourth period we'll obviously start at 4s. Every period, every nth period will start at ns subshell. It will end at np subshell. In between, whatever the or subshells are coming, they'll be filled. So like if you see 4s will be filled first, 4s ke baad you'll be filling 3d, and then you'll be filling 4p, and that will be the end of third period, fourth period. And that's why if you see, in this case, if you see the fourth period where we have got the potassium, we are starting at 4s1, it will be followed by 4s2, and then if you see 3d1 to 3d10 is being filled. Is it okay? And then 4p1 to 4p6 is filled for gallium to krypton. Is it okay? After that, इस बीच में we have got some exceptional configuration like chromium and copper. We discussed that in detail in the previous chapter, है ना. उसके बाद again we have to fill the 5s. So if you see, if you start at 5s, then you have to fill 4d and then 5p, and that will be the end of fifth period, है ना, because every nth period will start at ns, it will end at np. Okay, so 5s 4d 5p. So 5s से rubidium is started, then strontium 5s2, then if you see 4d1 to 4d10 is being filled, with many exceptions in fact in this period, we'll talk about that later, but generally roughly it is 4d1 to 4d10 filled in between S and P. And then if you see indium to xenon, 5p1 to 5p6 has been filled. Is it okay? Once you understand this part, na to fir periodic table में ज़्यादा load नहीं होता है. हाँ, obviously we will be talking about some of the exceptional cases. Otherwise, there will not be any load in terms of कि कौन सी चीज कहाँ पे आ रही है. ठीक है? हाँ, नाम धीरे-धीरे याद रखने पड़ेंगे. But in terms of configuration, if you understand it, you'll be able to imagine the whole periodic table next time. Okay? Now we are going to sixth period. Now यहाँ से फिर से कहानी change हो रही है. If you see sixth period, 6s will be filled. After that क्या fill होगा बताओ? 6s के बाद what should be filled after 6s?
4F.
4f. 6s, then 4f, then 5d, and then 6p. That will be the end of sixth period. Hai na? So this time the number of subshells getting filled in the sixth period have increased. Hai na? And that's why the number of elements will also be increasing. So that's why 6s. Now if you remember, if I'm writing the subshell and the capacity, and that will also give you why a particular number of elements are there in the period. If you see subshell and the max electrons which can be filled, so S के लिए it is 2, P के लिए it is 6, D के लिए how much? How many? Hmm? How many electrons can be filled
10.
in D subshell?
10.
10, है ना? Very good. And F में?
14.
14.
G में? There is something called G subshell, H subshell.
18.
Okay, so this is a pattern है ना? 18, फिर H आएगा तो फिर 22 and so on. Okay. Right now for currently discovered 118 element के लिए these subshells are not required to be filled. That's why we are not studying about these subshells. Otherwise, these subshells are existing. Now, so that's why if you see this one, so cesium is 6s1, outermost configuration is 6s1, then we are getting 6s2, and 6s2 के बाद we have discussed that 6s के बाद 4f की filling होनी चाहिए थी ना. Now we have got the exception. क्या नहीं? You're asking something? Okay. So 6s के बाद we should fill 4f then 5d ना. यहाँ पे there is an exception, and what is that exception? This lanthanum is an exception. Ideally, तो we should fill 4f first then 5d, but if you see the configuration of lanthanum, it is 5d1 6s2. So this is the first exception in that sixth period, that first we are filling the 5d1 and then we are entering into the F block where we have started filling the 4f electrons. So 4f, yeah, because D1 fill ho chuka tha, that's why when we are making D0, it will become 4f2, and then up to 4f14 we have filled from cerium to lutetium. Is it okay? And after the complete filling of 4f, na, we are coming back to here for filling of 6d, 5d. Is it okay? And then 5d2 से लेकर, if you see 5d10 तक we are filling from hafnium to mercury, and after that 6p will be filled as discussed. Is it okay? Again, the same pattern follows in the next period also, seventh period also. If you see in the seventh period, francium is having 7s, one outermost configuration, then radium. उसके बाद फिर से देखो, if you see 6, 7s के बाद, what should be ideally filled? 7s के बाद, what should be ideally filled? 5f है ना. But यहाँ पे क्या हो रहा है? Again we are getting the exception that 7s के बाद, 7s1 and 7s2 के बाद, first time we are filling 6d1 and then we are entering into the F. That's why I told you that our project is going for the same reason, that why we are filling 6d first and then we are entering into 5f, या फिर why we are filling first 5d1 and then we are entering into 4f. So because of that reason, that project is going on. But currently the status is lanthanum is considered to be in the D block. वो आगे बात करेंगे हम लोग block wise. So D is getting filled in lanthanum and actinium. But after that cerium से लेकर thorium तक, if you see यहाँ पर 4f2 से लेकर 4f14 दिख रहा है, मतलब 4f के electrons are getting filled. Thorium is again an exception. F block का element है, 5f is 0. I'll share those configurations बाद में उसको discuss करेंगे detail में. ये बहुत छोटा दिख रहा है because I want to show you the complete periodic table. We'll discuss these configurations in detail later, है ना. But thorium से लेकर Lawrencian तक we are saying कि they are the part of F block because F electrons are getting filled in the as the outermost द लास्ट इलेक्ट्रॉन। उसके बाद देखो फिर से आ गया रदरफोर्डियम पे, एंड देन यहां से जो फीलिंग है, ऑब्वियसली एनसीईआरटी हैज नॉट गिवन द इलेक्ट्रॉनिक कॉन्फ़िगरेशन, बट बाद के चैप्टर में इट हैज बीन गिवन। तो यहां से फिर से क्या होगा ना, D2 से लेकर D10 तक विल बी फिल्ड, एंड देन दीज आर 6D2 से 6D10 तक फिल हुआ, तो फिर से 7P1 to 7P6 will be filled to give you the 118 elements. Is it okay? Recently discovered elements are this 113, 115, 117 and 118. ये last 10 years में 2014-15 के बाद I think they were discovered, and the name of these elements are nihonium, moscovium, tennessine and oganesson. ठीक है, nihonium is the first element discovered by any Asian country, and that country is Japan, जिसको जापानीज में निहोन बोलते हैं, दैट्स व्हाई दे हैव नेम द एलिमेंट बेस्ड ऑन देयर कंट्रीज नेम, निहोनियम। एंड ये जो कहानी मैं सुना रहा हूँ, क्यों सुना रहा हूँ, देयर इज अ सेक्शन इन एनसीईआरटी इन व्हिच इट इज टॉकिंग अबाउट आईयूपीएसी नोमेनक्लेचर ऑफ द एलिमेंट्स। लाइक पुराने वाले पीरियोडिक टेबल देखोगे ना, लिखा रहेगा यूयूएन, यूयूबी, ऐसा कुछ कुछ लिखा रहेगा, है ना। तो दोज आर द आईयूपीएसी नोमेनक्लेचर ऑफ द एलिमेंट्स, जिनका ऑफिशियल नोमेनक्लेचर नहीं दिया गया है, because there was a history about this element 104 rutherfordium जो है ना, when this was discovered ना, multiple countries claimed simultaneously, यूएस ने भी क्लेम किया और रशिया ने भी क्लेम किया, उस समय उसको सोवियत यूनियन, तो both the countries claimed that कि they have discovered the element which is having atomic number 104, और वहीं पर से ये रूल बनाया गया कि IUPAC told us that कि whenever such type of controversy is coming ना, till now we are till the moment we verify the claim and we give the authentication to a particular country, IUPAC nomenclature will be followed, and उसके कुछ rules हैं जिसको हम लोग फ्यूचर में देखेंगे। बट उसमें से बोला कि जब तक हमने ये ऑथेंटिकेट नहीं किया तब तक आईयूपीएसी नोमेनक्लेचर चलेगा। द मोमेंट वी गेट द वी वेरीफाई क्लेम and we give the recognition to a particular country, then that country will be getting the right to name the element. लाइक रदरफोर्डियम यूएस ने बोला था, सोवियत यूनियन ने बोला था कुर्चाटोवियम, ठीक है। तो लकली ऐसा हुआ कि यूएस गॉट द क्लेम एंड दैट्स व्हाई दे हैव नेम्ड इट रदरफोर्डियम, अदरवाइज 104 को तुम अभी कुर्चाटोवियम बोल रहे हो, ठीक है। तो दिस इज द बेसिक स्ट्रक्चर ऑफ द पीरियोडिक टेबल। इज इट ओके? क्लियर पॉइंट? एनी डाउट? चलो नाउ एक एक करके अब इसमें हम लोग विल गो इन डिटेल की हाउ दीज एलिमेंट्स हैव बीन प्लेस्ड एंड व्हाट आर द प्रॉपर्टीज वी आर गोइंग टू एनालाइज। तो इफ यू ऑब्जर्व, जैसा मैंने बताया, एक एक करके सारे पॉइंट्स देखते चले जाते हैं। इफ यू सी, वी आर सेइंग दैट कि पीरियोडिक टेबल has been prepared based on the atomic number, because the modern periodic law says that the elements properties of the elements are the periodic functions of their atomic number, not of atomic mass, and that was based on the Mosley's X-ray experiment। if you remember, मैंने last chapter में बताया था कि he got the frequency of the X-ray radiation का square root to be the function of their atomic number, and at that time atomic number was simply meaning the placement of the element in the periodic table। बाद में पता चला कि what we are calling as atomic number, it is also equal to the nuclear charge, है ना। and that's why this was the property of element which was deriving all the remaining properties, and that's why it was decided after that, it was the story around 1913-14 के अराउंड की स्टोरी है। उसके बाद ये डिसाइड किया गया कि अब एटॉमिक मास की कहानी पीछे छूट गई, we need to arrange the periodic table, or we need to arrange the elements in the periodic table based on their atomic number and not on the basis of their atomic masses। and I told you earlier story कि मेंडलीव ने कहीं कहीं एटॉमिक मास उल्टा किया था, because उनका एटॉमिक नंबर was still in the sequence। एटॉमिक नंबर ऑफ आर्गन और पोटेशियम पे जाएंगे ना, एटॉमिक नंबर ऑफ आर्गन इज 18, एटॉमिक नंबर ऑफ पोटेशियम इज 19, एंड दैट्स व्हाई आर्गन के बाद पोटेशियम आ रहा है, बट एटॉमिक मास वाइज इट विल बी अल्टर्ड, है ना। दैट्स वन पॉइंट। ऑलरेडी आई हैव शोन यू दैट देयर आर 7 पीरियड्स एंड 18 ग्रुप्स। horizontal rows are called periods, vertical columns are called groups, and there are currently 118 elements। उसके लिए 7 periods are sufficient। is it okay? क्लियर है? नाउ इफ यू सी दिस पार्ट, जो मैंने बोला ये पीरियड्स ग्रुप्स की कहानी बताई ना, तो बाद में पूछेंगे वो हाइपोथेटिकली, मान लो 8 पीरियड आएगा तो क्या होगा, 9th पीरियड आएगा तो क्या होगा. तो वी नीड टू अंडरस्टैंड कि कौन से पीरियड का कंपोजिशन कैसा जा रहा है, एंड द नंबर ऑफ एलिमेंट्स इन अ पर्टिकुलर पीरियड इज आल्सो डिसाइडेड बाय द सबशेल्स गेटिंग फिल्ड in those periods. Is it okay? Clear a point? So that's why the next point, if you see, I told you that every nth period starts with an element having outermost configuration ns1, which are called alkali metals. बाद में इसको और भी डिटेल में देखेंगे. And ends with an element having outermost configuration this one. There is an exception. What is that exception? The first period. है ना? First period में we have what? Only hydrogen which is having 1s1 configuration, and it is ending at helium which is having 1s2 configuration, because we know that कि पहले period में तो we are not going to get any p वाला subshell, है ना. That's another part. Number of elements in nth period is equal to the number of electrons which can be accommodated in all the subshells filled starting from this ns up to np. Is it okay? And I've told you the capacity of the. Now if I ask you, just इसको analyze करो. If I ask you 8th period, how many elements you are expecting to be in 8th period? Can you tell me? How many elements we are expecting to get in 8th period whenever this period will be completely filled? How many elements we are expecting? Anyone? अभी जस्ट जो
सर
बताया उसी पे. हाँ जी.
36.
Why 36?
50.
Hmm?
50.
50. 36, 50. Okay, what is the basis of 50?
I use that 2 and square formula.
1 square. From
Yes.
that to.
See, because
Okay.
in the first group, first in the first pair there are 2 elements. In the second and the third there are 8 elements. Then in the
Okay.
fourth and fifth you see there are 18, and in sixth and seventh there are 32. So
Okay.
basically
But
it's for.
how are you taking the value of n?
So in
You are
the
taking it
first you see the n is the period number, right? In this
Will it
case,
be valid for third period or fourth period?
I think so.
Okay, let's put that for the third period. Are you getting 18 elements in third period?
I think yes.
No, there were 8 elements. Na? There are only 8 elements in the third period. Na? If you see, first period has got 2 elements, second period has got 8 elements, third period also has got 8 elements.
Okay.
Fourth period has got 18 elements.
Two,
Fifth
two.
has got 18 elements. Then sixth has got 32 and 32 elements. Sixth and seventh period. Okay.
Okay.
Okay. So I'll tell you why it failed. Because you are thinking that the nth shell is going to be filled in the nth period, which is a false statement. Okay. We are not filling the nth shell in the nth period. Clear a point? What we are filling, we are starting at ns subshell. We are completing np subshell. Whatever will be coming in between will be filled there. Is it okay? So that's why if you see, I'll tell you the pattern. 8th period to ठीक है, I'll be telling you up to 10th period. Let's see the pattern. How we are deciding that what are the periods, what are the subshells getting filled in different periods. If you see this one, this table, if you see, first period will be starting at 1s and it will be ended at also 1s. There is no 1p, na? And that's why first period was the exception where we are not saying that ns pe start hoga, np pe end hoga. First period will be started at 1s1 and it will be ended at 1s2, and that's why there is just 1s subshell getting filled, and that's why we have got two elements. Now, when we are talking about second period, it will be starting at 2s, it will be ending at 2p. And that's why the subshell getting filled are 2s and 2p. 2s ki capacity is 2 and 2p ki capacity is 6, and that's why we are getting 8 elements. Similarly, if I am talking about 3s, and you have to know the sequence, jo maine yahan n plus l rule wala bataya tha. Always you have to see this one, that If first period we are talking about 1s only, second period we are talking about 2s 2p, third period 3s 3p, fourth period 4s 3d and 4p, 5s 4d and 5p, 6s 4f 5d and 6p, 7s 5f 6d and 7p. That's the sequence we are going to get going to fill. And that's why if you see this table, in third period it is started at 3s, 3s के बाद 3p की filling होती है, तो we are filling actually 3s and 3p subshell, and that's why again we are getting 8 electrons in the third period. Fourth period, now we are coming to the next different period. We are starting at 4s. 4s के बाद जो होता है ना filling होती है 3d की, है ना, we are knowing that. तो 4s से start होगा, then we have to fill the 3d and then we have to fill the 4p. The capacity of 4s is 2 subshell wise. 3D is having capacity of 10 because it is having 5 orbitals. So we can fill 10 electrons and then 6 electrons for 4p. And that's why we have got 18 electrons, 18 elements in fourth period. Fifth period is the same case. 5s se start hoga, 5p pe end hoga. So we are filling 5s, 4d and 5p. And that's why we are getting 18 element again, 2 plus 10 plus 6. When we are talking about sixth period, we are talking about 6s se start hoga, 6p pe end hoga. But from 6s to 6p, if you see this sequence, we have got 6s, we have got 4f, we have got 5d, and then we have got 6p. And that's why we'll be starting the filling at 6s, then we'll go to 4f. Ideally, जैसे मैंने बताया कि there is one exception. But in sequence, if you see the complete period, obviously we are going to fill 6s से लेकर 6p, and that includes 6s, 4f, 5d, and then 6p. When we are talking about seventh period, obviously we'll start at 7s1, we'll end at 7p, but in between we have got 5f and 6p also. And that's why in these two periods, if you see, for S subshell 2, for F subshell 14, for D subshell 10, and for P subshell again 6. And that's why we are getting 32 elements. Is it okay? Eighth period will be started at 8S, will be ended at 8P. Now what subshells we are going to fill here, just see there. I told you that 5F के बाद 5GB होता है, लिखते नहीं है क्योंकि काम नहीं आता है, but the moment you start getting the 8th or 9th period na, you will be required to fill this one also, and that's why we have to write 5G also. We have to write 6F, 6G, 6H also. We have to write 7D, 7F, 7G, 7H, and then 7I. फिर we have to write 8P, 8D, 8F, 8G, 8H, 8I, 8J भी आएगा इधर, है ना, and so on. And that's why if I'm trying to fill 8th period, I'll start at 8S. उसके बाद क्या आएगा? 8S के बाद what are the subsets we are going to fill? 8S के बाद
5G,
5G, then
6F,
6F,
6F, then
7D,
70,
okay,
8P.
then 8P. Anything else?
no, then
No, because we are starting at 8S and we are leaving the period at 8P, है ना? And that's why we need to fill 8S, 5G, 6F, 7D, 8P. The capacity of S is 2. So we are filling 8S, we are filling 5G, we are filling 6F, we are filling 7D, we are filling 8P. If you add these, you are going to get 50. Is it okay? And that's why in similar cases, we are going to get 8th period and 9th period will be having 50 elements each. मतलब अभी तक 7th period तक we have filled only 118 elements. The moment we are filling the 8th and 9th period, na, we'll be covering 100 more elements then. And when we are talking about 10th period, it will be started at 10S and it will be ended at 10P. And now we'll be getting one extra subshell which is 6H. And H key capacity is 22. And that's why we'll be getting 72 elements in the 10th period itself. Is it okay? Any doubt up to this point? Now, because this has got the least number of elements, we call it the shortest period. ये सब नाम आए हैं अभी तक जितने periods हैं उतने पे. These two are called the short periods. These two are called long period. because it has got 18 elements. These two are called the longest periods. And I'm talking about only the periods which have been discovered yet. Okay. Any doubt up to this point? Okay, I want you to solve a question based on a paragraph. Solve this question.
Sir, is it C?
What? C, you
C.
are saying?
Yes.
Okay, I'll wait for other people also. You solve the next question also, I know.
Yes, sir.
So it's 2C.
What?
Second question C.
Second again C. Okay, I'll wait
Yes.
for that. Okay. Okay, why the answer of first question is C?
Sir, second also C.
Okay. Why C for the first question? Logic? Anyone? Anshul? Anshul, you have the logic
Sir, like देख
for the
के
first question.
yeah, for the first question वो like observation से ही I did it.
ऑब्जर्वेशन में कुछ तो एक आएगा. Why 12 you are saying? क्योंकि सब जगह 12 12 दिख रहा है. Why not 27 and 42?
नहीं like periodic table याद है ना, so that is why.
But I'm talking about it is a new rule, na? There
Hmm.
should be some logic. Okay, Anay, can you tell me the logic? Then why you have given the answer C? There should be some logic, na?
मतलब सर C आ गया समझ में, मतलब I don't know the logic.
Okay, okay. Okay, we need to understand it कि because अगला क्वेश्चन दूंगा तो फिर हिलेगा नहीं. I'm telling you. I'll give you the next question. हिलेगा नहीं. Okay. एक alternate language इसका क्या हो सकता है? हाँ. Anyone having any logic? Rehan? You have
सर
the logic?
इज इट बिकॉज लाइक थर्ड पीरियड में तो 3s 3p होगा इसलिए
हाँ. Okay.
तो उसके
Then
बाद मतलब आई डोंट नो हाउ टू एक्सप्लेन इट बट आई नो आई अंडरस्टूड हाउ थ्री
okay.
एस
I'll
और फिर फिफ्थ पीरियड में
Sir,
3s 3p और 5s 5p और 5d.
okay. I'll tell you how to explain it. है ना?
sir,
What it
can I?
says that maximum capacity of each orbital to be 3. That's the only thing it had changed. क्योंकि अगली
Sir,
बार मैं सब बदलने वाला.
sir,
हाँ जी.
can I tell you what I did?
हाँ बोलो ना.
I'm not sure if it is correct or wrong, but I'll
Not
tell
a
you.
problem. Not a problem. This class
So,
is about the discussion itself. है ना?
so see, the basic formula which I just told you above is 2n square. So instead of 2n square, it is written that they use 3. So I use the formula 3n square, and you know that we like in the first period there is 1, and then in the second and third we use the value of n is equal to 2. So in the third one
Okay.
we I
Okay.
used
So
n is equal to 2 and I got 12.
So your thing will work when you start taking the periods in pair after the first one,
Yes.
है ना?
Yes.
Okay, that's okay. That's okay.
Sir,
Now,
can I?
Haji, Haji.
Sir, they told instead of an two electrons in an orbital, there should be three. So in
Hmm.
S there should be three because there is
Hmm.
one orbital, and in P there should be 9 electrons. In D 15, and in F 21,
Yes, yes, yes,
and
yes.
then in
Yes,
third and
that's the
fifth is
basis. That's the basis. So in short, if you have increased the capacity of an orbital from 2 to 3, you have made it 3 by 2 times. है ना? Going from 2 to 3 can be understood that you have made it 3 by 2 times. And that's why every orbital is getting 3 by 2 times the number of electrons it was getting earlier. So every subshell will also be getting 3 by 2 times. So every period will also start getting 3 by 2 times the elements which it was getting earlier. है ना? So third period का original capacity was 8. Just make it 3 by 2 times. Fifth period का original capacity was 18. Make it 3 by 2 times. है ना? So if I am saying period number, actual number of elements, so if I'm talking about like first period अगर मैं बोलूं तो it was having 2 elements, second period was having 8, third was also having 8, fourth was having 18, fifth was having 18, sixth is having 32, and seventh is having 32. In this situation, and this is the hypothetical situation, obviously. Make everything into 3 by 2, है ना? That's why we'll say कि in this period we'll be getting 3 elements, we'll be getting 12, 12, 27, 27, 48, and 48. Now, if you see this question, तो first question का answer तो आ गया. Now, if I am talking about atomic number 9, if you see first period has got 3 elements, so it will end at 1s3 hypothetically. है ना? Second period will start at 2s, it will end at 2p, and you have got so 1s, 1, 2, 3 will be filled in first period. Second period will start at 2s, it will fill 1, 2, 3, and then 2p, 4 to 8, sorry, 4 to 12, 6 है ना? तो how many we have got? Sorry, 1 से लेकर 2p 1 से लेकर it will be 9 तक, है ना? Now if you see atomic number 9, 1s पूरा fill, 2s पूरा fill, and then 2p पे आ गया ना? If I am having z equals 9, so in this hypothetical situation, I'll write 1s3, 2s3, and then 2p3. So last electron is entering in p subshell, and that's why we'll be saying that it will be the part of p subshell. Is it okay? So that's why it will be the part of p block. If I'm talking about z equals 29, 28. See, if you see, add these three now, how many we have got? 3 plus 12 plus 12.
27.
27. So 28th element will be having the start 27 fill करने के बाद it will be started at the 4s1 है ना? It will be having like 1s3, 2s3, 2p9, and then 3s3, 3p9, and then 4s1 will be the configuration of this. So last electron is entering in s, and that's why it will be said to have s वाला में. Someone told me C option ना.
हाँ सर थोड़ा गलत हो गया.
थोड़ा नहीं पूरा गलत होता है. Now based on that we can say कि B option will be the right answer, but we'll check the other also. 42, how to decide? 42. Now you have got the idea. 42. How to decide? Hmm? 42. देखो ना लास्ट एलिमेंट ऐड करके देखो ना कहाँ पहुंच रहे हो. फर्स्ट पीरियड की कैपेसिटी 3, देन सेकंड की 12, देन 12, है ना. तो दैट गिव्स यू 27. 27 plus 27 becomes 54. And that's why we'll be saying 42nd element will be the part of the fourth period itself. And in fourth period, if you see, once you have inert gas, will have 27, है ना? We'll have 27, which is filled. After that, you'll be filling 4s3, 30 हो गया. And then, उसके बाद, if you remember, 4s के बाद we fill 3d. And we have got how many elements? 30 के बाद 12 भी चाहिए ना? And d की capacity is 15, है ना? That's why it will remain in the d वाला. That's why we'll say that 42nd element will have last electron in the d subshell, and that's why it will be the part of d block. So this was about z equals 42. Now if I say z equals 100, how to decide that? But because ये type के question तुमको real situation as well as hypothetical situation में they may ask. Z equals 100, how to get that?
The sixth period तक.
6th period number.
Okay, तो period तो पता चल गया. Once you add all these ना, so you'll be getting 27 plus 27 plus 27, 81 है ना. So we have got inert gas का configuration now as per this hypothetical situation 81, and after that I'll be filling the sixth period. It will be started at 6s3, है ना. तो 84 हो गया. Now we have got 14 elements. तो 6s के बाद if you remember 4f की filling होती है, and 4f के लिए how many electrons we have got? तो only 16, and 4f की capacity now has become 21, है ना. So it will be filled in f, है ना. Is it okay? Now, what could be the alternate language of this same question? They will write in this place, na, they'll write, they assumed 3 valid values for what? Can you tell me what I'm going to write? I'm talking about some quantum number.
Yes.
Spin quantum number, है ना? Why I'm saying
Spin.
that? Because what was this quantum number which was limiting the capacity of an orbital? It was spin quantum number, because spin quantum number was having only 2 valid values, plus half and minus half. And that's why we were saying, according to Pauli's exclusion principle, an orbital which is having exactly unique set of NLM must have only maximum 2 electrons, and both the electrons must be having 2 different values of spin quantum number. And that's why we are saying 3 valid values of spin quantum number अगर तुमने assume कर लिया, so it will have the same impact, है ना. 3 valid values of quantum spin quantum number will give you the maximum capacity of an orbital equal to 3, and that's why everything will be 3 by 2 times. So this is an alternate language they may use. Is it okay? अब एक tough question दूं? Okay, let's try it. Now I'm going to change everything. Everything means literally everything.
Sir, I didn't understand the question.
So I have given you. Okay, basically what this question says na, कि जितनी the periodic table was arranged on the basis of electronic configuration that we have understood today itself, है ना? Now, when you are following that electronic configuration, you are following a particular sequence with the known shells and subshells and orbitals, है ना? We say we are having 1s, 2s, 2p. Now it is talking about a hypothetical situation where those were not the actual quantum numbers. Now we have got a different set of quantum numbers with different valid set of values. So you have to go from the scratch. You have to create your own shell, subshell orbitals, and then only you can start filling those subshells. Okay, that's the situation. And advanced ka exam ka questions can be at this level. Obviously, this is not for mains. Obviously, mains में इतना नहीं जाएंगे. But advanced का question may give you a situation where they'll be actually checking it कि exactly रट्टा मार लिया है कि they are understanding it also. So if you understand the basic construction of the periodic table, which I explained earlier, तो उसकी basis पर now you have to create your own set of quantum numbers and the shell, subshell and orbitals, and then only you will be able to fill it, है ना? Okay. You want to try it now or you want it as homework? सोचना चाहते हो इसको क्या? टाइम लेके थोड़ा सोचो, है ना? नेक्स्ट क्लास आई विल डिस्कस दिस पार्ट, ठीक है? Okay.
So you will send this screenshot in the group, right?
I'll send this PDF just after the class. Okay.
Okay,
Okay.
sir.
Whatever we are studying now, after every class, I'll be sending you the PDF of that lecture. Okay. Don't worry about that. है ना? You'll be getting this question as a homework. So I'm giving you as homework. इसको जरा सोचना. ठीक है? सोच लिया तो बहुत अच्छी बात है. I'll be the happiest person. क्योंकि बेसिक सी है बट उस पे नाउ वी हैव गॉट, इफ यू रिमेंबर, जैसे मैं हिंट देता हूँ, n का वैलिड वैल्यूज क्या होता था? ऑल द पॉजिटिव इंटीजर्स है ना, 1 2 3 4 5 6. दैट डेफिनेशन इज स्टिल सेम. बट l के लिए वी वर गेटिंग ओनली 0 to n-1 वैल्यूज, है ना? दोज वर द वैलिड वैल्यूज. दिस टाइम वी हैव गॉट अ डिफरेंट डेफिनेशन, है ना? वी हैव गॉट द डिफरेंट डेफिनेशन दैट जैसे n इक्वल्स 1 है ना, तो अभी l का वैल्यू पहले सिर्फ 0 होता था. लाइक 1 में सिर्फ s क्यों आता था? बिकॉज l का वैल्यू सिर्फ 0 वाज पॉसिबल वैल्यू, है ना? दिस टाइम इट सेज it is all the integers from 1 up to n plus 2. Now we have got l ka value for n equals 1, l ka value 1, 2, 3. So first cell will get now 3 subcells. And the name of those subcells will be, new names are there. It has been given. NA, NB, NC ऐसा जा रहा है, तो 1A, 1B, 1C will be the subcells of the first cell. Every subcell will have number of orbitals decided by the values of m, है ना? And that is having a another thing. Now, what do you mean by integral step? That means you go from the lowest value, you add 1 at a time. ठीक है? मान लो मेरे पास वैल्यू आ गया, l का वैल्यू 1 है, तो फिर m का वैल्यू क्या होगा? तो -12, and then you add 1 in that, so you'll be getting +12. बट मैंने बोल दिया अगर l का वैल्यू 2 है. नाउ कैन यू टेल मी m का वैल्यूज क्या क्या आ सकता है?
-1 to +1.
व्हाट आर द नंबर्स? 2 नहीं, सारे नंबर्स बताने.
-2, -1, 0, 1, 2.
-2 क्यों?
-1,
Minus
This is the new definition. ध्यान से देखो. This time it is -l/2, which is -1.
0, 1.
Then you keep adding 0, keep adding 1 and reach up to +l/2, which is +1. Okay. l equals, मान लो 3 बोला. Now we have got m का value -3/2. Add 1 in that, so we are getting -12. Add 1 in that, we are getting +12. And add 1 in that, we are getting plus 3/2. So these many orbitals we are now getting in different subshell. So A subshell will have 2 orbital, B subshell will have 3 orbital, C subshell will have 4 orbitals, and so on. Okay, so that's the way you have to think about this question, है ना? इसको जरा try करके do some brainstorming, है ना? Then you'll be really happy कि ठीक है, you are able to crack these questions. ठीक है? Now what I want to do today, periodic table को थोड़ा सा hold पे डालते हैं. Why I'm putting it on hold? Because there is a concept which will be regularly used, but we generally teach that concept as the part of 8th or 9th chapter, which is called volumetric analysis or redox reaction. There is a concept of oxidation state जिसको पढ़ाते ऑफिशियली हम लोग बहुत बाद में है. अगर किसी भी कोचिंग के पैटर्न में जाओगे तो वो बहुत बाद में पढ़ाया जाता है, बट इट विल बी सो यूजफुल इफ यू लर्न इट राइट नाउ ना, कि उसको मैं यहीं पे पढ़ा देता हूँ. ठीक है, तो आई गिव यू द बेसिक आइडिया. हाँ, उसके लिए क्वेश्चंस की जो लिस्ट होती है वो मेरे पास 200-250 क्वेश्चंस की लिस्ट होती है. आई गिव यू दैट क्वेश्चन, वो थोड़ा थोड़ा हर दिन करने का है. देन यू विल गेट टू नो कि क्या हो रहा है. तो हर क्लास के स्टार्ट में मैं क्या करूंगा ना, आई विल बी डिस्कसिंग 20-30 स्मॉल प्रॉब्लम. मतलब आई विल बी गिविंग अ कंपाउंड, बोलूंगा इसका ऑक्सीडेशन स्टेट किसी एक एलिमेंट का बताओ. तो ऐसे 20-30 हर बार करके हम लोग आगे बढ़ेंगे, सो दैट वी कैन कंप्लीट इट ऑल्सो, है ना. तो आई एम एंटरिंग इनटू द न्यू सेक्शन ऑफ द of not obviously this chapter, but एक नया concept ही discuss कर लेते हैं आज, and that is the concept of oxidation state. What do you mean by the concept of oxidation state? So it is simply a real or imaginary charge for an atom in a given state or in a given substance. So like if I'm talking about oxidation state, what do you mean by that? जैसे एक दो example करके देखते हैं, then you will understand it. Like if I'm talking about NaCl, and if I ask you what is the oxidation state of Na and Cl in NaCl,
Plus
so
one
we know
minus two.
that NaCl is nothing but Na plus and Cl minus. ना, this is ionic compound, है ना. Ionic covalent ये आता है ना थोड़ा बहुत. Ionic bond का मतलब क्या है? Electron will be completely transferred, and that is the interaction between the cation and anion, है ना. What about covalent bond?
Sharing.
Electrons are shared, है ना. ठीक है, then we call it covalent. So like this is ionic bond, this is having this compound. भले ही हम लोग लिख रहे हैं NaCl, but we know that it is Na plus and Cl minus, and that's why if they are asking in NaCl oxidation state of Na in NaCl is how much, so what will you say? It is the real charge over it, है ना, +1. That's why we'll write +1. And if I ask you oxidation state of Cl in NaCl, how much?
-1.
-1. It will always be reported with a sign. ठीक है, and this is the year जिसमें ऑक्सीडेशन स्टेट का ही क्वेश्चन पूछ लिया था. हाँ, we know that कि वो थोड़ा सा टफ था because you need to know the structure, otherwise you can't solve it. But this year JEE 2023 में ऑक्सीडेशन स्टेट का क्वेश्चन was present in the JEE advanced का question. ठीक है, okay, I'll give you another example. Let's talk about H2O, simple water. If I ask you what is the oxidation state of oxygen or hydrogen in H2, how to get that? So for that, पहली बात तो we need to know the structure. बाद में I'll give you a mathematical method also. But normally if you know the structure, so like I know the structure that oxygen is connected or bonded with two hydrogen atoms in covalent bond. There is no real charge over it. What we have to do now, we have to identify, अच्छा electronegativity पता है क्या थोड़ा बहुत? Okay, I'll tell you in one line that it is the tendency to pull the shared electron towards itself. So when I say there is one atom is more electronegative than the other, then that first atom will have more tendency to pull the shared electron towards itself. Now if I say electronegativity wise, F is the highest, and right now if I say simply O is greater than H, तो बाद में ये पूरा list बताऊंगा. But if I say O is more electronegative than H, so shared electron will be more closer to which atom, O or H?
O.
O के पास. Now while deciding the oxidation state, जिसके ज्यादा पास रहेगा ना उसको complete transfer करवा. Okay, what we are saying that whatever bond is there ना उसको break कर दो hypothetically, and then the shared electron will be coming to the more electronegative atom. So whenever I'll be breaking one bond, the more electronegative atom will be getting -1 charge because it has got one extra electron, and that electron was lost by hydrogen, and that's why it will be getting +1. Is it okay? Understood क्या? Now if I break this bond, बताओ किसको क्या मिलेगा? If I break this bond, second one, O will get what?
1 electron.
One negative charge. One electron.
-1, and H will get
Positive charge. +1.
+1.
Positive.
Now, if I ask you, what is the oxidation state of O in H2O?
-2.
-2.
So we'll count the total charge, है ना? So we'll say oxidation state of O in H2O is -2. Now, if I ask you what is the oxidation state of H, तो क्या बोलोगे?
+2.
No, it will always be reported in per atom terms.
So
Okay,
+1.
so we'll say oxidation state of each H atom.
+1, right?
So then we'll say it is +1. Is it okay? Any doubt up to this point? Now I'll make a structure and I want you to solve it. If I give you H2CO3 and I'll give you the structure also. You tell me the oxidation state of each element in this compound H2CO3. This is called carbonic acid. इलेक्ट्रोनेगेटिविटी वाइज बता देता हूं मैं ऑर्डर, धीरे धीरे वो याद भी कर लेंगे. So we'll say O is more than C, C is more than H.
Sir, carbon का +4.
Okay, so I'll be breaking the bond. While I am breaking CO bond, O will get -1, C will get +1. When I am breaking CO bond again, this will get -1, this will get +1. When I am breaking this bond, then what will happen?
So C will get
We have
+1.
broken a double bond, so C will get +2 and O will get -2. Is it okay? Similarly, if I break this bond, O will get -1,
Sir,
H will get
oxygen का -6.
Okay, देख लेते हैं. मैंने क्या बोला था यहाँ पे?
Plus
Reported
-2, right?
per
Oxygen.
each atom. Huh?
The
Oxygen
+1, +4,
-2.
-2.
Okay, so when we are reporting it, na, oxidation state of, if there are multiple atoms, we report it like oxidation state of each O in H2CO3. Then what will say? It is -2 है
-2.
ना? तो कहीं भी आ रहा है तो -2 में ही आ रहा है ना? So that's why we'll say -2. When I'm talking about oxidation state of each H in H2CO3, how
+1.
much?
+1.
+1. And if I ask you oxidation state of carbon, there is just one carbon.
+4.
+4.
+4. Okay, let's solve one more. And I'll give the structure. This is a structure of H2S.
So same, hydrogen is +1, oxygen is -2, and sulfur
Okay.
is
+6.
Sulfur is?
+6.
+6.
+6.
Okay. If we break this one, this will get +1, -1, -1, +1, -1. If I'm breaking all these bonds, no, this will get -2, this will get +2, this will get -1, this will get +1, this will get -2, this will get +2, and this will get -1. This will get +1 यहाँ से, है ना? So that's why we'll say oxidation state of S in H2SO4 is +6. Oxidation state of each O in H2SO4 is -2, and oxidation state of each H in H2SO4 is +1. Now, if I ask you, what is the total of these two numbers?
0.
0.
Okay. What about this one? Is the total 0?
No, -1.
Okay, but you have got two hydrogen. No?
Yes.
So if I add the total summation of oxidation state of all the atoms,
Zero.
then we'll say this is this much and this is this much. If you add this 0, we are getting. Okay. Now if I ask you H2CO3 mein, if I simply keep the total, na, we are not getting 0. But if I write -2 into 3 plus 1 into 2 and plus 4 into 1, we are going to get 0. Is it okay? Clear है ना? चलो एक और क्वेश्चन करके दिखाता हूँ, then we'll get another. If I give you
Sir, plus 6 or
okay,
minus 2.
okay, okay. So basically, if I break all the bonds around Cr, we are getting +1, +2, +1, +2. We have got total +6. If you break this bond, this is getting -1 from this side, -1 from this side. This will get +1, +2, +1, +2. This will get -1. This will get -2, and this will get -1. Now, एक तो दिख रहा है each Cr is getting +6 oxidation state. Can we say each oxygen is getting -2 oxidation state?
Yes, sir.
What about the terminal one? ये बाहर वाले?
Sir, they are getting -1.
उनको -1 मिल रहा है.
-1.
ये वाला?
-1.
ये वाला -2 है ना? Okay, this is not getting -1. This is also getting -2 only. There was a real charge also. And it is the total charge, real or imaginary. Okay. So now in case of Cr2O72 minus, we'll say that oxidation state of each Cr is equal to +6 and oxidation state of each oxygen is -2. Summation is obviously not 0, but if I do +6 into 2 and if I do -2 into 7, बताओ जरा total कितना आ रहा है?
-2.
-2. Why -2?
So
अभी तक तो 0 आ रहा था.
वो total charge compound.
This is equal to the total charge on the substance. If it is ion, then the summation of oxidation state of all the atoms will be equal to the net charge on the ion. Is it okay? Clear? Now we are getting some pattern. देखो ना, ऑक्सीजन अभी तक जितना किया सब जगह -2 आ रहा था. जितना हाइड्रोजन का किया एवरीवेयर इट वाज गेटिंग +1, है ना? तो यहां से कुछ कंक्लूजन्स आएंगे एंड दैट विल गिव यू अ मैथमेटिकल मेथड आल्सो. Now we want to get a mathematical method so that we don't have to know the structure most of the time. There will be some cases in which I'll tell you कि बिना structure के नहीं हो पाएगा, but most of the time we will be able to handle the questions without knowing the structure. ठीक है? So there are some general rules which we are going to follow. जैसे first rule is if I am having any element in its elemental state. Elemental state can be like sodium in the form of sodium itself, Cl in the form of Cl gas or Cl2 gas. Cl के बीच में even there is bond, उसको ब्रेक करेंगे तो कोई ज्यादा या कम इलेक्ट्रोनेगेटिव नहीं है ना. And that's why what we'll say जैसे example में we'll write oxidation state of Na in sodium solid will be 0. Oxidation state of Cl in Cl2 will be 0. Oxidation state of P in P4 will be 0. Oxidation state of O in O2 or in O3 will be 0. Oxidation state of sulfur in S8 will be 0. Is it okay? अब देखो यहाँ क्या है, S8 मैंने जैसे लिखा, there is a molecule called S8. It is having structure like crown shape बोलते हैं इसको. This is the structure of S8 molecule. But the problem is, if I break any bond, no sulfur is more or less electronegative. Na? They are identical atoms. And that's why they are not going to get any charge because of breaking of the bond. And that's why we'll say every sulfur is in zero oxidation state. Is it okay? Clear? So that's first rule, that whenever we are getting any element in its elemental state without ion, without any ionic charge. ऐसा नहीं कि मैंने बोला I और I3 माइनस बोल दिया या I माइनस बोल दिया. That is not the point. So in elemental state without any charge, we'll say the element का oxidation state will be zero. Is it okay? चलो second
सर
rule
तो
पे चलते
O जब भी O2 बनाएगा तभी उसका ऑक्सीडेशन स्टेट जीरो
हैं.
रहेगा.
तो if someone is saying O2 में O का oxidation state कितना है तो we'll say zero. O3 में कितना है तो zero. S का S2 में या S4 में या S8 में पूछेगा we'll say zero. ठीक है. There is no other element, there is no charge over that, है ना. So that's why F2 में F का पूछेगा zero. H2 में H का पूछेगा zero. Is it okay? Now let's talk about the second. Second rule is about monoatomic ion. मोनोएटॉमिक आयन का मतलब क्या? Na प्लस Cl माइनस F माइनस S2 माइनस N3 माइनस ऐसे वाले आयंस, वहां पर वट एवर इज द चार्ज that itself will be called the oxidation state. For example, if I am talking about oxidation state of Na in Na plus, it is monoatomic ion, है ना? There is just one atom and there is charge over it. So we'll say it will be plus one. If I say I want to know oxidation state of calcium in calcium 2 plus, it is plus 2. Now you tell me oxidation state of sulfur in S2 minus. कितना होगा?
-2.
Minus 2. Oxidation state of nitrogen in N3 minus.
-3.
Okay. Oxidation state of H in H plus and oxidation state of H in H minus. What is the answer of
1 plus
the first?
+1
Plus 1
-1.
and
plus
minus 1.
minus 1.
So now, based on that, I have given you the hint that we need to be careful. H plus है या H minus. That also we have to see, है ना? So if H is coming with non-metal, it is always coming in +1 oxidation state. But if it is coming with metals like CaH2, calcium is metal, and that's why H will be coming in -1 oxidation state. ये आगे देखेंगे. Understood ना अभी तक? Now third rule which I told you is about a compound or a compound ion. What do you mean by that? तो पहली बात तो ऑलरेडी मैंने Cr2O7 2- दिखाया था ना. Like what I'm saying, for example, in if I say KMnO4, which is called potassium permanganate, we'll say 1 into oxidation state of K plus 1 into oxidation state of Mn plus 4 into oxidation state of O will be how much?
Zero.
It will be 0 because the compound doesn't have any net charge, है ना, over it, and that's why we'll say 0. But if I say in Cr2O7 2-, if I say 2 into oxidation state of Cr plus 7 into oxidation state of O will be how much?
-2.
-2.
-2. Now I want you to write the same thing for N2H5 plus. It is called hydrogenium ion.
+1.
Plus 1.
What will be equal to plus
2 into OS of N plus 5 into OS
1?
of H.
Okay. And plus 5 into oxidation state of H will be equal to +1. Understood now?
Yes.
Now, if you see, we have got a mathematical equation. Can we solve these equations?
Yes.
How?
By
I've
putting
got three answers. In the first equation, I have got 3 unknown. How to solve it?
So
We'll
the
draw the structure
oxidation
of
state,
स्ट्रक्चर ड्रॉ किया तो
oxidation
फिर मैथ काम काय को आएगा? फिर तो स्ट्रक्चर से तो करते ही रहते ना. Now I'm trying to get escape from that structure वाला method, है ना. I'm trying to bring everything to mathematics, and that's why I've got one equation. Like first equation has got 3 variable, second equation has got 2 variable, third equation has got 2 variable. But one variable can be solved only for one equation, है ना. One equation, one variable can be solved. So that's why out of all the variables available, na, we need to fix all the variables but one, है ना. किसी एक को छोड़ के बाकी कहीं से फिक्स कर देना पड़ेगा. और वो फिक्स करने के लिए नाउ साइंस विल कम इनटू द पिक्चर. विल हैव सम ऑब्जर्वेशनल रिजल्ट्स. लाइक आई टोल्ड यू ना, ऑक्सीजन हर जगह -2 दिख रहा था ना. तो जैसे ही मैंने बता दिया कि ऑक्सीजन को -2 ले लो, द मोमेंट आई टेल यू कि ऑक्सीजन को -2 ले लो, तो सीआर का निकल आएगा ना मैथ से. इवन इफ यू डोंट नो द स्ट्रक्चर ऑफ Cr2O72-. जैसे मैंने बोल दिया हाइड्रोजन का +1 ले लेना, तो यू विल बी एबल टू गेट द नाइट्रोजन का ऑक्सीडेशन स्टेट ना. इज इट ओके? एंड दैट्स व्हाई इसके आगे का जो काम है ना, दैट विल बी अबाउट दोज ऑब्जर्वेशनल रिजल्ट्स. इज इट ओके? सो व्हाट आर द ऑब्जर्वेशनल रिजल्ट्स? Those results are about various compounds. Like I'll give you a list of compound elements जिनके बारे में already observations are there with some limitations obviously. Special cases की बात अलग से करेंगे. जैसे if I'm talking about any heteroatomic compound or compound ion, F will always be -1. F is the most electronegative atom which forms only one bond. एक ही बॉन्ड बना रहा है एंड इट इज द मोस्ट इलेक्ट्रोनेगेटिव, तो इट विल ऑलवेज गेट -1. एंड दैट्स व्हाई एनी कंपाउंड, जैसे कोई भी बोल दे HF में बताओ, CaF2 में बताओ, कितना भी कॉम्प्लिकेट कर दे, Na3AlF6 में बताओ, OF2 में बताओ, कहीं भी ऐसा कुछ कर दे, विल से F इज इन -1 सीधा. आई कैन गिव यू इवन मोर कॉम्प्लिकेटेड ये. लाइक इफ आई गिव यू COF6 3-, if I give you O2PTF6, ऐसा कुछ भी लिख दूं ना, देख लिया कि हेट्रोएटॉमिक है और उसमें F है, तो F विल बी -1. सिंपल. कितना भी कॉम्प्लिकेटेड लिख दो. इज इट ओके? वैसे ही अल्कली मेटल विल ऑलवेज बी +1. जैसे आई विल गिव एन एग्जांपल, जैसे यहां पर एग्जांपल दिया, कोई भी कितना भी कॉम्प्लिकेट कर दे. लाइक इफ आई से Na2SO4, if I say NaOH, if I say K3PO4, if I say K4FeCN6, इतना कॉम्प्लिकेट कर दे तो भी the alkali metal, which means group 1 metal, will have always +1 oxidation state. Is it okay? Alkaline earth metal will have always +2. For example, if I say CaCO3 में Ca का will be +2, MgNO3 twice, Mg का +2, okay, BeCl2, Be का +2. Is it okay? That's third. Zinc will have +2 and Al will have +3, है ना. अभी ऑलरेडी दे दिया, Al का एग्जांपल दे दिया, AlOH थ्राइस, Na3AlF6. कोई भी बोल दे, जिंक का कोई भी दे दे, ZnCl4 2-. जैसे यहाँ ZnCl4 2- लिख दिया, ZnOH ट्वाइस लिख दिया, इन सब में Zn विल बी +2. एल्यूमिनियम का कोई भी लिखूंगा तो आई राइट, जैसे AlPO4 लिख दिया, Al2SO4 thrice लिख दिया. In all these examples, Al will be +3. And I have talked about all the examples without any exception till now. है ना. कहीं भी ऐसा नहीं बोला कि नहीं, it can have some exception. Always is this much. इतना लिखा है ना. Now let's talk about hydrogen. I told you earlier also, hydrogen if bonded with non-metal will be coming in +1. Hydrogen when bonded with metal in ionic hydride, it will be coming in -1. So for example, oxidation state of H in HCl, H2O, H3PO4, H2SO4, HNO3, NS3, N2H5 प्लस, N2H4, कुछ भी लिख रहा हूं, ये सब नॉन मेटल्स के साथ आ रहे हैं, NH4 प्लस, सीधा प्लस, simple. But if I say oxidation state of H in NaH, CH2, MgH2, etc., इन सब में जैसे आया मेटल के साथ आया माइनस, any doubt up to this point? Now when the oxygen will come, it will have some exceptional cases also. So for oxygen we need to be careful. Generally it is coming in -2. So when I'm saying generally, what are the examples? जितना अभी तक example किया सब वैसा ही केस था. Oxidation state of O in H2, NaOH, कुछ भी ले लो ऐसा, Ca3PO4 twice, Cr2O7 2 minus, KMNO4, K2MNO4, etc. will be -2. But there are 3 special examples and we need to be careful about that. If it is getting OO link, देखो क्या होता है ना, जैसे एग्जांपल दे रहा हूं मैं, if I'm talking about this example, जैसे if I'm talking about H2O2, this is one example. The structure is like this. Now if I ask you, what is the oxidation state of hydrogen here? Can you tell me? If I break this, H will get what?
+1.
+1. If I break this, H will get what?
+1.
And O has got -1. ये भी O has got -1. If I break this, what will be obtained by O and O?
0.
0 and 0, na? There is no electronegativity difference. Both are identical atoms. That's why, if you see, now if I ask you, oxidation state of H, it is +1. But if I ask you oxidation state of O, it is how much? It is -1. Is it okay? And that's why I told you, whenever we are having this peroxy linkage, this is called peroxy linkage, OO bond is there. Or if it is ionic peroxide, like if I'm having, another example can be, if I'm having कोई भी एक ले लो, जैसे K2O2 ले लिया, ठीक है. इफ यू सी, ऐसे केसेस में क्या करना है ना, just to identify कि what is the charge over the oxygen or what is the form of oxygen here, remove the cation. K के पास कितना चार्ज होता है, अभी जस्ट सीखा था थोड़ी देर पहले. How much will be the charge over the oxidation state? +1 always. So 2K will take 2 plus ना. तो if 2K is taking 2 plus, तो ये क्या रहा होगा, O2 पे 2 माइनस रहा होगा, तभी तो नेट 0 हुआ होगा. इसका मतलब we have got this peroxide, and in peroxide, oxidation state of O will be -1. Is it okay? Let's talk about superoxide. Superoxide में जैसे एग्जांपल है, if I say KO2, can you tell me K plus अलग किया तो बाकी क्या बचा?
O2 minus.
O2 minus, ये बचा ना? This is called superoxide. Now you can apply mathematics also. If I say oxidation state of, मान लो oxidation state of O is X. अभी जो सीखा था वो अप्लाई करो जरा, मैथमेटिकल इक्वेशन क्या लिखेंगे? 2 into X will be equal to what?
-1.
-1, because the total charge over this is -1, है ना? And that's why we are saying X is how much?
-1/2.
-1/2. And that's why in superoxide, oxidation state of oxygen is -1/2. दो मैसेज है. It is not integral, it is negative, and that too is fractional, and it is not -2. Is it okay? So oxidation state can be fractional also इस साल का क्वेश्चन उसी बेसिस पे था. दे आस्क्ड यू, नॉट फ्रैक्शनल एग्जैक्टली, बट दे आस्क्ड यू कि कितने एलिमेंट्स हैं जिनका ऑक्सीडेशन स्टेट 0 आ रहा है इन द गिवन कंपाउंड. उसकी बात करेंगे आगे हम लोग, बट यहां तक समझाना. Now, if I am talking about fluorides, already I told you that fluorine will always be getting -1. So based on that, we can calculate the oxidation state of oxygen. And whenever oxygen will be bonded with fluorine, because fluorine is more electronegative, oxygen will start getting plus oxidation state. है ना? Oxygen will have positive oxidation state, and we need to calculate by taking oxidation state of fluorine equals -1. And we can do that. है ना? So if I'm talking about this fluorides wala case, what is that case? It is actually, जैसे in example, as an example, if I take OF2, can you tell me oxidation state of oxygen here?
+2.
तो मान लो ये X था, we'll write 1 into X plus 2 into -1 for fluorine, and that will be 0, and that's why we are saying X is +2. अब धीरे धीरे मैं तुमको और शॉर्टकट दे रहा हूँ, बार बार इतना इक्वेशन लिखने की जरूरत नहीं है. क्या करने का है आगे फ्यूचर में? I have got OF2. I'll be writing oxidation state at the top. I'll be writing total summation at the bottom. ठीक है? तो I know that F is -1, तो total कितना हो गया?
-2.
-2. And OF2 के ऊपर टोटल चार्ज 0 करना है, तो यहाँ क्या रखना होगा? +2.
+2.
And there is just one oxygen, तो oxidation state will be +2. Okay? If I give you K2Cr2O7, O का ऑक्सीडेशन स्टेट जनरल इज -2. टोटल कितना लिख दूं?
-14.
ओके. K का ऑक्सीडेशन स्टेट
+1.
टोटल.
+2.
Okay. What should be the total for Cr?
-12.
-12 plus 2 -14 will become नेगेटिव में आ जाएगा पूरा. टोटल अपने को 0 चाहिए ना? क्या लिखो तो टोटल 0 हो जाएगा? What should we write here so that total will
तो
become 0?
12 भी आएगा ना?
It will be +12, है ना?
हाँ,
Sorry.
CR का
If
6 ही होता है क्योंकि वैसे.
if 2 items are getting +2, नहीं, Cr का फिक्स नहीं होता है 6.
तो लाइक
It
वो
can be 3 also.
एग्जेम्पशन पे वो चेंज था.
हाँ, तो अभी के लिए we are getting 2 atoms के लिए we are getting +12, so we'll be getting +6 here. Is it okay? Clear ना? Any doubt? Okay. Can you tell me? अभी जस्ट किया था, बट आई वांट यू टू सॉल्व दिस. इसमें नाइट्रोजन का बताओ. हाउ टू डू? H का क्या लूं? ऑलरेडी टोल्ड यू. H का व्हेन बॉन्डेड विद नॉन मेटल वी टेक H के लिए +1. H का +1 नीचे क्या लिखूं?
+5.
+5. अभी यहाँ कितना लिखूं?
So
-4.
so nitrogen is -2, right?
ओके, सो यहाँ टोटल विल बी राइटिंग -4 so that we get net
So each
+1.
will be -2.
That's why each will be +2. Is it okay? Understood ना?
So +2 or -2?
So
हाँ?
-2 आएगा.
Sorry,
rest of it will-
-2. Okay? Clear ना? Any
Yes.
doubt?
No.
Okay. If I ask you, we have got Ca3PO4 twice. P का बताना है. Can you tell me?
सर एक
O का कितना? O का कितना? -2 नॉर्मल वाला केस है.
-1.
स्पेशल केस में अलग से बताऊं.
1 आएगा.
मैं कितना लिखूं यहाँ नीचे?
So B is -1, right?
No.
+1.
Okay, tell me O का total. O का total. How many O we have?
-8.
-8.
नहीं ना. How many O we have?
4 है. 4.
-6.
Oh,
8 होगा सर.
8 है.
हाँ उधर आ
-16 रहा है.
Ca का +2
so B
total
is
+6.
+6.
so B
Here
-6.
we have got total
तो PO4 का
+10.
-3 होना
माइनस
चाहिए.
So P is
PO4 का
-3.
टोटल चार्ज -3 होता है. आई एम टॉकिंग अबाउट P का कितना. That we want to know.
-5.
यहाँ पे we have got 2 phosphorus and that's why per phosphorus we have got +5. There is
plus
another way. If you know the ions, na, we
So
know that it is calcium 2 plus and PO4 3 minus. है ना? Now we can do the calculation. Is it okay? That's another way. हाँ जी, any doubt?
हाँ सर, वो वैल्यूज को 2 से मल्टीप्लाई करने की जरूरत नहीं है, डायरेक्ट डिवाइड कर सकते हैं ना, +6/3 करके।
+6 upon?
लाइक CA3 जितना उसका आंसर 6 है, +6,
हाँ,
उसको अपॉन 3 कर दिया तो डायरेक्टली आ गया +3, तो
तो
PO4
वो
का
तो मैं बता
-3
ही
आ
रहा हूँ ना
गया।
कि फॉस्फेट का चार्ज इज -3 दैट
हाँ
सपोज
तो
वैसे भी इफ यू नो
हाँ
दैट तो काम हो गया अपना, है ना? ओके,
सर वो
हाँ जी बोलो।
लीनियर इक्वेशन का मतलब वे भी यूज कर सकते हैं ना क्वेश्चन
हाँ,
के लिए?
उसी को शॉर्टकट में मैंने बताया। आई एम यूजिंग द सेम थिंग, ठीक है?
ओके सर।
आई एम यूजिंग द सेम थिंग बट आई एम यूजिंग इट इन अ प्लेस कि बार बार इक्वेशन कौन बनाएगा, वही काम कर रहे हैं अपन। वी आर नॉट डूइंग एनीथिंग एक्स्ट्रा, सेम थिंग वी आर डूइंग ना। देखो ना, समेशन को जीरो कर रहे हैं ना, इफ दैट देयर वाज नेट चार्ज जीरो, है ना? वी आर डूइंग द सेम थिंग बट एट वन प्लेस। वी आर नॉट राइटिंग होल थिंग बिकॉज वी आर ट्राइंग टू सेव द टाइम। इफ यू डोंट गेट द कॉन्फिडेंस, राइट दैट इक्वेशन, नॉट अ प्रॉब्लम, बट देयर विल बी टाइम व्हेन यू विल गेट कॉन्फिडेंस इफ यू कीप डूइंग इट, ठीक है? ओके, चलो, तो एक और बच गया, हेलोजेंस की बात नहीं की अभी तक। हेलोजेंस के लिए फ्लोरीन का ऑलरेडी आई टोल्ड यू दैट इट विल बी -1 इफ इट इज नॉट इन एलिमेंटल स्टेट। बट बाकी हेलोजेंस का क्या होगा? बाकी हेलोजेंस व्हेन बॉन्डेड विद लेस इलेक्ट्रोनेगेटिव, दे आर ऑलवेज फॉर्मिंग वन बॉन्ड एंड दैट्स व्हाई दे विल बी इन -1 ऑक्सीडेशन स्टेट. But when they are bonded with more electronegative atom, then they will be getting positive oxidation state and that has to be calculated based on the other things, है ना? तो like for example, if I say NaCl में Cl का, so it is bonded with less electronegative. Metal are less electronegative than the non-metals, है ना? That's why we'll say कि Cl will have oxidation state equals -1. Is it okay? If I write CaBr2, okay, no problem. So now, if I write CaBr2, calcium is metal, Br is non-metal. So non-metals are more electronegative. Calcium is less electronegative. So that's why we can directly write oxidation state of Br will be -1. Even if they are complicating it, like मैंने दे दिया ऐसा, ऐसा कुछ लिख दिया. Even then, we can directly write nickel is metal, chlorine is non-metal. So oxidation state of Cl is -1. But if I give you HClO4, now, Cl is bonded with O. There are two ways, either by the structure or by the calculation. Can you tell me Cl का oxidation state in HClO4, HClO3, HClO2 and HOCl?
First one is -7.
No. I told you it is bonded with oxygen, so it will be getting plus oxidation state somehow, no? Two methods. एक तो equation वाला. If you then is still comfortable with the equation, तो मैं क्या बोलूँगा? 1 into +1 हाइड्रोजन के लिए plus 1 into x for chlorine plus 4 into -2 is equal to 0. And if you calculate that, you will be getting x equals +7. Another method which I told you, if this is -2, total is -8. If it is +1, total is +1. So we need to put +7 here, you know? And that's why it will be +7. That's another method. बताओ अभी दूसरे में Cl का, HClO3 में
Plus
HCl, हाँ जी,
+5.
+5. If you go by the method, 1 into +1 plus 1 into x plus 3 into -2 is equal to 0. And that's why we'll be saying x is plus. Okay. वैसे यहाँ पे करोगे 1 into +1,
+3.
1 into x. Now you have got the pattern also. It is 0. So we'll say x is equal to +3. इसमें बोल दो पहले ही.
+1.
Okay. So 1 into X for chlorine and plus 1 into -2 for oxygen. And that's why we'll write X will be +1. Is it okay? Any doubt? That was for halogen. Now, just to give you the idea, electronegativity का idea देने के लिए I am giving you the numbers. Numbers आगे पढ़ेंगे भी हम लोग कहाँ से आए हैं, कैसे आए हैं. But I'll be giving you some numbers which will help you to decide which is more electronegative, which is less electronegative. And there is a pattern for important elements I've given you. If you see now, if I'm going from, I told you earlier also, F is the most electronegative, then oxygen, है ना? Now, if you go from, it is in the sequence of periodic table. If you see periodic table वाला ही sequence है. If you go from air to air ना -0.5 करते जाओ. Every time.
तो वैल्यू याद रखना है.
नहीं अभी के लिए तो बिल्कुल भी नहीं. फ्यूचर में भी जेई के लिए नहीं चाहिए, बट कुछ क्वेश्चन तुमको मिलेंगे जिसमें they'll be asking you कि इलेक्ट्रोनेगेटिविटी इतना इतना है तो फिर क्या होगा उसका इम्पैक्ट, जो हम लोग मेन चैप्टर ऑफ द मेन पार्ट ऑफ द चैप्टर में पढ़ने वाले हैं. इलेक्ट्रोनेगेटिविटी विल बी वन ऑफ द प्रॉपर्टी विच वी आर गोइंग टू लर्न. ठीक है, बट आई टोल्ड यू कि एक पैटर्न बता देता हूं मैं जस्ट टू हेल्प यू. ये देखो -0.5 हो रहा है, नेक्स्ट टाइम इट इज -0.4, नेक्स्ट टाइम इट इज -0.3 एंड देन एवरी टाइम इट इज -0.3. phosphorus and hydrogen has got almost same electronegativity. CSI US का एक सीरीज है, टीवी सीरीज, they have got almost identical electronegativity. Br is in between Cl and I है ना, तो 2.8 जैसा है. This is just to give you the idea कि which is more electronegative, which is less electronegative. Is it okay? Now one last point and then we'll end it, and then I'll send you some questions so that you can solve some question based on oxidation state as well as पुराना वाला तो एक होमवर्क दिया ही है periodic table वाला. Some elements have got some minimum and maximum oxidation state. Now कभी कभी धोखा हो. I'll give you a compound जिसमें पूछूंगा सल्फर का कितना होगा, and right now I'm telling you the maximum oxidation state of sulfur can be +6 only. I've written it here. मतलब it can never be more than +6. But if I give you a formula जिसमें you are getting sulfur का +7, so there are two parts. पहला part कि जैसे ही 6 से ज्यादा है 6 लिख दो. ठीक है. The moment you start getting more than 6 for sulfur, you write there 6. For chromium, if you start getting more than +6, you write 6. For manganese, if you start getting more than 7, you write 7. Is it okay? That's one trick. But why we are getting wrong answer by calculation? जैसे I'll give you an example. If I say H2S2O8, can you tell me सल्फर का कितना आ रहा है? सल्फर का बताओ जरा.
+7.
+7, जबकि हो ही नहीं सकता. So that's why we need to write +6. So
तो
oxidation
फिर इधर
state
एक ऑक्सीजन का -1 होगा ना.
हाँ, तो क्या हो रहा है कि when you have done the mathematical calculation, you assume that all the oxygen are in -2 oxidation state, जबकि जो actual structure होता है ना for this compound, this is the structure. Now if you see, ये जो बीच वाले दो ऑक्सीजन दिख रहे हैं, वो peroxy link वाले दिख रहे हैं ना, that's why they are in -1 and -1. While doing the mathematical calculation, you have assumed 8 into -2 किया होगा ना, and that's the wrong part you have done. But that will give you the hint. The answer will give you the hint if you take care of the maximum वाला. Okay, तो maximum value अगर जो दिया गया है उससे ज्यादा आ रहा है कैलकुलेटेड वैल्यू, राइट द मैक्सिमम वैल्यू एंड यू अंडरस्टैंड दैट कि उसमें देयर मस्ट बी अ पेरोक्सी लिंक. जैसे आई विल गिव यू अनदर एग्जांपल, एकदम बहुत ही ड्रास्टिक एग्जांपल. इफ यू सी CrO5, Cr कितना दिख रहा है कैलकुलेशन से, कितना आ रहा है? +10 आ रहा है.
+10.
आई टोल्ड यू कि Cr +6 से ज्यादा हो ही नहीं सकता है.
हाँ तो
We'll write oxidation state of Cr equals +6 and it is having a special structure which is called butterfly structure. It looks like this.
Butterfly.
Yeah, its name is butterfly structure. This is the structure of CrO5. Now, if you see, there are 4 oxygen atoms which are in -1 oxidation state. है ना? O bond वाले जितने दिख रहे हैं, this is -1, this is -1, this is -1, this is -1. Only this is -2. And while doing the calculation, you have assumed that all of those are in -2, and that's why you are getting wrong answer. Is it okay? Now, one last point, that average oxidation state can be sometimes fractional also. I'm giving you a list. जरा observe करना. If I report individual तो क्या आता है, and if I observe average तो क्या आता है. ठीक है, just इसको करके आओगे next time पे. I'm giving you the structure also, and these are the structures this time JEE 2023 में पूछा गया है. एक ये पूछा, एक ये पूछा, एक ये पूछा, एक ये पूछा और एक कोई और पूछा था. I don't remember exactly. मैं दे दूंगा लास्ट में क्वेश्चन. But these were the structure. If you see, ये सल्फर को कितना मिलेगा बताओ जरा.
0.
0 ना. इस सल्फर को
0.
0.
what about this sulfur?
Five.
Plus 1.
+5.
Plus
Ah.
5.
What about this sulfur?
+5.
Plus 5.
So if we have been asked how many atoms are in 0 oxidation state, we'll say 2. If they are asking what are the oxidation states of sulfur in Na2S4O6, we'll say +5, 0, 0, +5. But if they are asking you average kitna hai, can you tell me average oxidation state of sulfur?
2.5.
2.5, which is a fractional number. Hai na?
Yes, sir.
Will be, because total is +10 and there are 4 atoms. That's why we are getting +2.5, which is a fractional order. है ना? And these are the examples written in NCERT, and that's why JEE is giving so much of importance of these compounds. है ना? Br308, Na2S4O6, C3O2, this is called carbon suboxide. ये सब दिया हुआ है NCERT में, and that's why JEE Advanced is even picking it. Okay. चलो, तो I'll be sending you these notes. एक बीच में क्वेश्चन दिया था, उसको जरा सोच के रखोगे. I'll be sharing a list of questions about oxidation state also. I'll be sharing an assignment. उसको ट्राई करके रखोगे. Next time again we'll be coming back to periodic table. ठीक है? We'll be understanding that block wise what type of classification we have done and what are the properties in different blocks that we are going to analyze in the next lecture, and then we'll enter into the properties of elements. ठीक है? चलो क्लोज करते हैं ना. Okay, chalo, okay, bye everyone.
Bye,
Bye,
sir.
Thank you, sir. Bye, sir.